Chapter 3, Polynomial and Rational Functions. So Chapter 3, Polynomial and Rational Functions. If you have questions for me, I can stop anytime. There is no problem. Okay, so when it comes to polynomial functions, the first function that we looked at was linear. We know how to graph it, we know everything about it, and this is the general form, ax plus b. A number times x plus b. So this is a polynomial function, degree 1, first degree. The second one that we already know the graph, so to speak, is quadratic. Quadratic function. And we graphed it many times using transformations. So the two shapes of the quadratic functions are when we say it holds water, it has a minimum, and when it has a maximum. We graphed this function before, so we're going to start here. We're going to analyze the quadratic function and then continue. Continue to what? We're going to continue to a cubic function. Let me write here the general form that we already know, ax squared plus bx plus c. The cubic function is a polynomial, so this is degree 2. The cubic function will have degree 3. And we're going to look at also degree 4. Fourth degree polynomial function. So this is degree 4. We're not going to go beyond degree 4. So this is what we already know, no problem there. And we're going to continue with quadratic, and then eventually we'll get to cubic in the 4th degree. After we finish these, we're going to look at the rational functions. And that will be the end of chapter 3. And that's when we have test 3. I moved it a little bit. We'll talk about it at the end of the class or next time. I moved it a little bit for another week. We'll see, maybe we don't need to do that. We'll see. We'll go through these steps. Okay, so we continue with quadratic. When we graphed quadratic functions in the past, we used transformations. So quadratic functions. Again, the general form is ax squared plus bx plus c. Now, what we need to know is when the leading coefficient, when a is a positive number, the graph, which is called a parabola. So the graph of a quadratic function is this, or the other shape. It's called a parabola. So the parabola in this case has a minimum when the leading coefficient is positive. When the leading coefficient is negative, the parabola, the graph of the quadratic function, will look like this, which means it will have a maximum. Okay. First step, I would like us to go through the steps of graphing. Graphing a quadratic function. So I am going to pick a function from page 382. So for example, 32 on page 362, and the function is f of x equals 5 minus 4x minus x squared. So in order to graph, so the question is asking us graph f of x. We have several steps to go through. Here is the first step. Domain. It's a polynomial function. All polynomial functions have domain, all real numbers. Domain, negative infinity to infinity. Very friendly functions, no restrictions on the domain or on x. Always domain, all real numbers. Step number 2. I need to identify whether the parabola opens upward or the parabola opens downward. And that is given by the leading coefficient. But this parabola, or this quadratic function, I should say, this quadratic function is not arranged in the correct order. We have to rearrange it. Can anyone give us the correct order, descending order of the parabola, so I can write it?
Negative x squared minus 4x plus 5.
Excellent. Now let's identify the leading coefficient.
It would be negative 1.
Indeed. Because it's a negative leading coefficient, I know the parabola looks like this. So the parabola will look like this, and not like this. It will have a maximum. Good. Step number 3. X-intercept. And I will put in parentheses if they exist. How come? Just a side note. So we already know that the parabola has a maximum. In which situation the x-intercepts will not exist? In this situation. If the maximum value is somewhere negative, the x-intercepts will not exist because the function does not cross the x-axis. In another situation, if it's a minimum, then in this situation, the x-intercepts will not exist because the minimum is a positive value. So in this case, no x-intercepts. In this case, no x-intercepts. So how do I find the x-intercepts for any function, including the quadratic one? How do I find the x-intercepts for any function? Anyone, please? We set
We'll set the equation equal to 0.
Indeed. We set the function or the equation, if you want, negative x squared minus 4x plus 5 equals 0. Indeed. If you remember, I said, please refuse to solve a quadratic equation or any equation with a negative leading coefficient. Refuse. So always multiply both sides by -1. The solutions will not change if you multiply the equation both sides by -1. So now I have x squared, I have 4x, and I have minus 5 equals 0. Maybe this is factorable. If it's factorable, I should factor it right away. If it takes too long, use anything else. Apps in the calculator, quadratic formula, anything else. So is this factorable?
Yes.
How do I factor it?
4, positive 4, positive x plus 4, x plus 1.
Careful.
Oh, no. Oops. Never mind.
The product
X
is
minus 5 and x plus 1.
There you go.
right. So x squared minus x plus 5x and minus 5. Very easy to check. Even if you come up with something, you should always say, take a moment and check. X squared minus x plus 5x is 4x. And 5 times -1 is indeed -5. Always take a moment and check. So then, can anyone give us the two solutions? The x-intercepts?
-5
Yes,
+1.
yes, indeed. So we found the x-intercepts. They are -5, 0, and 1, 0. Number 4, y-intercept. That will always exist. How do I find the y-intercept? For any function, any equation.
Set x to 0.
Indeed, very good. 0, 0. So how much is y?
5.
Indeed. So we found 0, 5. Excellent. Good. Number 5, the max point, or the point of maximum. So we established that the function has a maximum right here. How do I find the coordinates of the maximum? And here is the formula. The coordinates of the maximum are these. For the x, -b divided by 2a. And the function value at this point, f of this, -b over 2a. So remember the function is, one more time, -x² minus 4x plus 5. Let's identify a, b, and c. Can anyone give us, again, you already gave me a. Can anyone give us b and c? Although c is not in the game, let's identify it as well. Can anyone give us b?
-4.
Excellent. And of course, c is 5. In order to determine the x coordinate of the maximum, I have to calculate this ratio. -b over 2a. Negative is from the formula. b happens to be -4. 2 times a. 2 times a happens to be -2. When you see in this setup 3 negatives, you know the answer is negative. And 4 over 2 is 2. So this point, the maximum or the minimum, is also called vertex. Only parabolas have vertices, plural. Don't say when we get, let's say, to a polynomial of degree 3 or 4, you can never find a vertex. This is typical. So this is characteristic to a quadratic function. Typical to a quadratic function. You will not find a vertex anywhere else. Okay?
2, -2. Right.
So the vertex, in this case the maximum, has the x coordinate -2, but now I have to plug in the function. I have to plug in -2 and see what I get. Okay, so I'm going to share my screen. And we're going to always, please get used to this idea of plugging in the function in y equals. It's always easier and better to look at it like that. And you can always come back and evaluate for something else. Who knows? -x², remember when you start with a negative, you have to start with this symbol. And then minus, the regular minus, 4x, and then plus 5. And now with second and table, I want to evaluate at -2. It's waiting for me. Maybe I may want to evaluate for something else. The function is there already. So the coordinates of the vertex, or the maximum in this case, are -2, 9. Again, f of -2 is 9. Okay, this was number 5. Again, let's summarize, recap. A lot of steps here. Domain. Identifying whether it has a maximum or a minimum. We did. Number 3, x-intercepts, if they exist. Number 4, y-intercept. Number 5, the vertex. In this case, it was a maximum. Number 6, and there is a 6 and there is a number 7. In 6, axis of symmetry. What is this? So every time we graph a parabola, I'm not talking about odd or even functions. Every time we graph a parabola, let's say I'm graphing a parabola with a maximum. Here's the maximum. Before I get to this step, I have to plot the vertex first and then show a dashed line that is vertical and it goes through the vertex. This is what it's called the axis of symmetry. But notice that it's the same thing with the x of the vertex. Because if this is, let's say, 2, 8, this line has to be x equals 2. And the maximum is y equals 8. So the axis of symmetry is the line at any shape. It doesn't matter. All parabolas have an axis of symmetry. So I always have to graph it just to show that these two sides are symmetric. I have students who graph the parabola like this. This is unacceptable. My graphs are not perfect, far from being perfect, but not like this. So you have to show that this is the vertical line passing through the vertex, and these two pieces are as symmetric as possible, not like this. That's the purpose of the axis of symmetry, to make us or help us keep the graph in shape, not one side very close and the other one very far away from the axis of symmetry. Good. So the axis of symmetry we know is x equals the x-coordinate of the vertex. X equals -2. Finally, because it has a maximum, I have to find the maximum value. But the maximum value is the y value of the vertex. All I have to say is 9. We completed all the steps that we needed to complete in order to graph this parabola. You can say a lot of steps. It's better to use transformations. Yes, but this function, the way the function is given to us, we don't want to use transformations because we have to complete the square first. No, 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 no. So when the function is given to us like this, we go through these steps. We have another possibility when the square is completed. I'll show that in a minute. Okay, so all I have to do next is simply graph the function. So, ready. I always start with a vertex. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here it is. That's the vertex, -2, 9. Then, the axis of symmetry, which is not part of the graph, it's a dashed line. I have to write it as x equals -2. It's a dashed line, vertical, going through the vertex. It will help me keep the graph in shape. Now the y-intercept. The y-intercept is 0, 5, 2, 4, 5, right here. Then the x-intercepts, and I'm done. -5, 0, 2, 3, 4, 5, 0, and 1, 0. That's all I need. Carefully, do not graph the parabola like an absolute value, not too acute at the vertex, but still keeping it in shape. Always write the name of the function. We graphed -x² - 4x + 5. From the graph, number 8, finally, can anyone give us the range of this function? The range of this function.
negative infinite to negative 2.
Careful, the range. Negative infinity till
9.
very good. Negative infinity till 9. Any questions on how to graph a parabola? Any questions, please? Do we need to go through another example? Please let me know. Do we need to go through another example? I don't hear anything.
Yeah, can we go through one more?
Yes, please. Sure. Okay, so let's take a look at 27. And we have f of x equals x squared minus 2x minus 3. We're going to try to go through the steps faster this time. Good. Step number 1. Can anyone give us a domain of this function?
Negative 2.
Yes, it's a polynomial function, very friendly. Can anyone identify if it has a minimum or a maximum? Only one is possible. Of course, not both.
Mid.
Positive.
Yes, because the leading coefficient is positive. Yes, it's a minimum. So the vertex will be a minimum. Perfect. Number 3, x-intercepts. The order is not important. You can change the order if you please, if you like. How do I find the x-intercepts? If they exist, of course. X-intercepts, please. How did we find them before?
Set y to equal 0.
Indeed. Y equals 0, so we have x squared minus 2x minus 3 equals 0. If it's not factorable, it doesn't have to be factorable. If it's not factorable, I have to find the solutions, approximations with a graphing calculator. That's fine. So can we factor this? Can anyone factor x squared minus 2x minus 3 for us?
X plus 3
You mean x minus 3? And?
x plus 1.
Good. So we have two solutions. X equals and x equals. And the ordered pairs we just determined.